Welcome to an example in which we're solving 4 sine squared minus 19 sine minus 5 equals 0. These are not easy. I'm going to bring them down and I'm going to just make it an S, or just to make things a little easier here. Okay. So now, what am I going to do? I'm going to show you first. So the first step is we have to factor. Let me just call it factoring in general. So we have to factor. Factor means we have to do two parentheses. We have to make this, see how this is things subtracted? We have to make it two things multiplied, make them factors. Factors are things multiplied. So we have to make this into multiplied. How do we do that? Well, I'm going to have a trick for you. Here we go. You grab the number in the front and you go times the back. You multiply the front number times the back. Yeah, this is a trick, by the way. This isn't legal. Let me just say it's a trick. It's not, it's a math trick. It's not, you can't really just grab the front number and multiply the back. It's illegal. Yeah, you can't just be grabbing numbers and moving around. But this is a special trick which will make life a little easier for you here. That'll be 20, right? 4 times 5 is 20 equals 0. So I multiplied the number in the front, the 4, times the number in the back times 5, 20. Okay. So now we're going to factor this. So step 2. Find two numbers that multiply to equal the back and add to equal the middle. Remember how it works? This is multiply, add, multiply. I'm looking for two parentheses, and there's going to be S here. Let me just go back to, this is going to be S here and S here, because S times S multiplies to be S squared. Okay, then what's going to go at the back? What are two numbers that multiply to be 20? Well, first off, what multiplies to be 20? Well, 4 times 5 multiplies to be 20, right? And so does 2 times 10, and so does 1 times 20. Those numbers all multiply to be 20. We'll do the negative thing in a minute, but they multiply to be 20. So how do you know which one you want to use? Well, they have to also add to be 19. So which of those? Can 4 and 5, what do they add to be? 9. 2 and 10 add to be like 12. 1 and 20, they had to be 21. But if you subtract them, if you add a negative, 20 and minus 1 is 19. There we go. That's our pair. So 1 and 20. You could put the 20 first. You put the 20 here and then the 1. It doesn't really matter either order. So, okay, so that's the pair we want. See how I decided that? That pair multiplies to be 20 and can add to be the middle term. Now, the sign in the middle has to always go on the bigger number. And this will be plus. See how that's right? Because plus 1 minus 20 adds to be minus 19. And positive times negative multiplies to be negative 20. So there we go. Now, step 3, because up on step 1, we multiplied by the front number, now divide both numbers by the old front number. So see, we multiplied by 4. Now I'm going to go divide by 4. Divide by 4. See right there? Okay, and I'll say and reduce any fractions that you can reduce. And so this can be 4 goes into 20 5 times, right? So then what do we have at this point? Now we have S plus a fourth, and we have S minus 5 equals 0. So that's a trick step. You just see that? Now there's actually one more trick. And then finally, step 4, move denominator to the front. So grab this and put it right there. So you get 4S plus 1. The other one, this guy doesn't have a denominator, so just leave it as it is. S minus 5 equals 0. Again, this is a trick. You can't really be moving denominators like that, but it works. It's a nice little trick somebody came up with. We factored it, meaning this is the right, we're not completely done yet, but this is the major part. This right here is the factorization of this. Meaning if I was to take 4s and go boom, boom, and boom, boom, multiply that all out, 4s times s be 4s squared, and, do the whole thing, you would get this right here. It would actually work correctly. So it's a little trick for factoring. Okay, so now that we have that done, you know what comes next. Step 5. Each part equals 0, meaning you take just this part, 4s plus 1 gets its own equals 0, or the second part, s minus 5, all by itself equals 0. Now, why? I hope you know why that is, because that one, no, we're done with the tricks. That is just pure logic. Why? Well, because these guys are multiplying, right? Two parentheses are multiplying to equal 0. If I said, hey, I'm multiplying two numbers and the answer is coming out equal to 0, what does that mean? The first one could be 0, like 0 times 7 would be 0, or the second one could be 0, like 3 times 0, for example, would be 0. The first one is 0, or the second one is 0. If two numbers are multiplying to be 0, either the first one's 0 or the second one is 0. That's what we just did, right? Two things are multiplying to be 0. So the first one is 0, or the second one is 0, okay? So that's just logical. So now let's finish up from there. I'm just kind of erase that. There we go. Now finish this up. So -1 for both those. Boom. So 4s equals -1. Divide by 4. Boom. S equals -1/4. And then over here, let's add 5 to both sides. Boom. S equals 5. So now we got S alone. So let's go back. What was the original question? This is sine, isn't it? This really says sine of x equals -1/4. And then we'll say or, and then over here, sine of x equals 5. Okay. So now we're getting close. Now, how do we finish the process? We've got to finish this and finish this. What are we going to do? Well, at this point, we look and we say, this is not on the unit circle. In fact, that's the case for both of them. Those numbers are not on the unit circle. If we had those nice unit circle numbers like a half or square root of 3/2 or square root of 2/2 or 0 or 1, those numbers that are on are negative, it needs to be negative. Those numbers that we deal with all the time on the unit circle, those answers on the unit circle, then we would just look and find usually the two angles that'll make the half or the √3/2 or the √2/2 or the 0 or the 1. And those would be our two answers from this part and the two answers from that part. But these numbers are not on the unit circle, so we can't go to the unit circle. What do we do when we can't go to the unit circle? Well, that's why we have the notes. So I specifically gave you in the notes, number 3 here, when we must use the calculator because the values are not in the unit circle, what do you do? After getting sine, cosine, tangent alone, we've got sine alone. Then take the inverse sine, cosine, or tangent of both sides. But before hitting the inverse in the calculator, change the number on the other side to be positive. Oh, okay. So let's do that. Change to +1/4 and do sine inverse. Sine inverse of positive. You got to change that to positive. Remember that process? So let's do that. I'm going to do it with my calculator right now. Oh, and make sure you're in radian mode. Radian mode. So I will do that. Am I in radian? No, I'm not. I'm in degree. Okay, there we go. I'm in radian. I'm going to hit sine inverse of 1/4. I'm getting x equals, because it's still x, right? X equals. So notice what I basically did is I just did sine inverse of this side and sine inverse of that side, but I changed it to positive. These canceled out, so x is alone. And the other side, I changed to positive, hit the buttons on the calculator. We get 0.25268. Now, that's step 1. Realize now that your answer is an angle in the first quadrant because we changed the right side number to be positive. So that's not our real answer. We made it positive because remember the all students take calculus, all the functions are positive in the first quadrant. So this is a first quadrant answer. So part C, we need to find the two quadrants where our answer will be using all students take calculus. So we go back and go, oh, yeah. So I'm going to do that. Remember this whole thing. All are positive here. Students take calculus. So we're looking, what was our original question right here? Sine is negative before we changed it. So we're still answering the original question. We just changed it to positive for a minute to get a good number on our calculator. But really, we're answering the question, where is the sign negative 1/4? So where is the sign negative? This question, quadrants 1, 2, 3, and 4. It's 3 and 4. Sine is negative. Sine is negative, right? Because all the functions are positive in the first, so sine's not going to be negative there. And the second, sine is positive, so it's the third and the fourth where sine will be negative. That's our original question, sine negative. That's what it's saying in the notes here. It's saying, find the two quadrants where our answers will be, like meaning the original question, where is sine actually negative? We changed to positive just to help us with the calculator, but really we're answering where's the sign negative? Quadrants 3 and 4. So then I go, okay, so I need a quadrant 3 answer and I need a quadrant 4 answer. How do you get those? Formulas are right here. Third quadrant, pi plus the calculated value. Fourth quadrant, 2 pi minus the calculated value. So I'm going to go, oh, okay. So it's pi minus this 0.25268 answer. And this is, or no, plus, sorry, pi plus, right? Wasn't it plus? Yeah, plus. For the third quadrant, pi plus. And for the fourth quadrant, 2 pi minus. This will be 2 pi minus 0.25268. Let's see what we get. So I'm going to hit buttons on my calculator now. Second pi plus the answer. So I'm getting 3.39427. That's there's one of my answers. And the other one, 2 pi minus, I'm going to go. Okay, so 2 pi minus. I'm getting 6.03050. Okay, so there's the two, those are the two answers where the sign is going to be negative 1/4. We just saw this. How did we do it? We changed to positive just for hitting the buttons on the calculator, got the calculator value. Then we found the actual two quadrants where sine is really negative, right? Because we're trying to, we're trying to answer the question, sine negative 1/4, sine negative 1/4. So we said, oh, all students take calculus, going to be the third and fourth quadrants. And we grab the formulas down here for the third and fourth quadrants. Make sure you have this during the exam. This will really help you. Third quadrant, pi plus the whatever you got out of your calculator. Fourth quadrant is 2 pi minus whatever you got on your calculator. Get those two numbers. Those are two answers. Now we also need to do the other side over here. Sine is 5. Again, that's not in the unit circle. So what's our first step? Hit sine inverse on both sides, because that'll cancel this out. Get x alone. When you hit sine inverse of 5 in your calculator, you'll get air. Why? Because there's no answers from that side. There's no way, there's no angles where sine is ever 5. Sine can't be 5. You remember the graph of sine? Remember, it goes up and down, up and down. It only goes up to 1 and down to -1. See, there's nothing in front here, which means the amplitude is just 1. There's no way it's ever going to go up to 5. There's no answers out of that side. So our only two answers are these two. Those should be our two answers. Is that what they said in the beginning? That 6.03 and 3.39. Is that right? 6.03, 3.39. Yeah, there they are. We got the two answers. So recapping real quick, what did we do? From the beginning, we took this, wrote it with S's, and then we said, okay, and then we take that, then we do the factoring trick. We take that number in the front, multiply the back, make it 20, find the two numbers that multiply to be -20, add to be -19. That was -20 plus 1. And then since you multiply by that 4, now divide them both by that 4. Reduce this fraction to be 5, move that one up there, Move the denominator back, and 4s plus 1, s minus 5 is your factorization. Now set each one equal to 0 separately. Solve for it. So s is minus 1/4 or s is 5. That means sine is minus 1/4 or sine is 5. Now, those are not in the unit circle, so we have to hit it. If these were numbers on the unit circle, like a half or square root of 3/2 or root 2/2 or 0 or 1, then I would just get my answers off the unit circle. But these are not. These numbers are not in the unit circle, so I have to hit sine inverse on both sides. But remember, the notes tell you change to positive when you're going to use your calculator. Take that minus 1/4, change to positive, hit sine inverse, get that answer, but then you still have to answer the question, where is sine negative 1/4? We do the all students take calculus, where's sine negative, third and fourth. Formulas for the third and fourth, pi plus what you got in your calculator and 2 pi minus what you got in your calculator. There's the two answers. The other side, when we hit sine inverse of 5, it just goes air on our calculator. So it's just calculator air. So that means there's no more answers. There's not going to be two answers this, and there's not going to be 4 answers altogether. There's just the original 2 we found. Those are the only 2 answers. Put them in separated by commas, and there we go. Just as easy as that.